For the following linear equations, solve the given variable and graph the solution. So here's a review of what we've done the past 2 days. You're trying to isolate your variables with inequalities and make sure that you're using those rules. 2 is greater than x, therefore x is less than 2. We multiplied with inequalities. Oopsies. And we also learned that when you divide by a negative, the sign flips, because the number line flips from positives to negatives and negatives to positives. It says, why do we flip the inequality sign when multiplying or dividing by a negative? Because the number line flips in order. So you used to go 1, 2, 3, 4, 5, and then now the number line goes -5, -4, -3, -2, -1. The order flips, so we flip the sign. This is just a review. Now, 5-3 is solving inequalities with multiple steps, not just adding or subtracting or simply multiplying and dividing. So we've done this in the last chapter. We used equations. So we ask ourselves, how do we get the variable by itself? Well, here you have to get rid of 17 and you have to get rid of 2/3. Get rid of 17 first by applying the inverse. It was negative, so you're going to add. How do you get rid of multiplying this 2/3? Multiply by 3/2. So this is going to become 90 divided by 2, which is 45. So you had to do 1 step, 2 step. So 45 is greater than A, therefore A is less than 45. These are the kind of problems that are going to be in your homework for tonight. If you look at W here, you have to get rid of 3 and you have to get rid of dividing 2. In order to get rid of dividing 2, you multiply both sides by 2. So it's going to be W plus 3 is less than -16. Then you can subtract 3 from both sides and W is less than -19. This isn't going to be crazy. This is just like chapter 2, solving equations, except we're solving inequalities. Now, we have to simplify before we solve. This equation seems a little complicated, but it's not. There's just a lot going on. There's a lot of cleaning to do. So I use the distributive property, and now I have to combine like terms. If I have a 3e and an 8e, don't move anything, just clean it up. We simplify before we solve. This side you can't simplify anymore. Now, to get rid of your e's, you can get rid of 11e or you can get rid of 12e. I'm going to get rid of 12e because I want to keep everything on the left-hand side. So I'm going to end up with -1e. And then subtract 4 on both sides, and you're going to get -1e is less than or equal to 2. If I'm going too fast, you're more than welcome to pause and rewatch. But this is just a repeat of chapter 2. That's why I'm kind of going fast. But go at the pace you need to. When I divide by a negative, we just said the sign flips to stay true, and this is our equation. None of them asked us to graph the solution except for up here. So let's go back real quick and make sure we're doing everything right. If we're less than 2, we have an open circle and we're shading to the left. If we are less than 24, we have an open circle and shade to the left. If we are greater than or equal to, the circle is filled in and we shade to the right. So this is a review and what we're going to be doing. Also, word problems. We've done word problems. So let's review word problems that we did in chapter 2. It says the sum of 4, so we have to have addition, sum. When I'm starting out, I would always write the symbols. The sum of 4 and twice a number is 52. So the sum of 4 and twice a number is 52. Okay. Those words are now translated into algebra, and you can solve from there. They didn't ask you to solve, though. They just want you to write algebraically what the verbal words mean. It says 1/2 of its multiplication. So 1/2 of a number equals 16. It says if 5 times a number is decreased by 12, the result is 5. Okay, so 5 times a number decreased by 12, the result is 5. Okay. Now, remembering this from chapter 2, we're going to apply it to chapter 5-3, multi-stepped inequalities and word problems. So let's translate. If x is at least 5, x is equal to 5, but it can also be greater. If m is at most 6, m can be 6, but it can't be more than 6. It's at most 6, so it's less than. And z is between 7 and 8, and when it says inclusive, that means not only is it between it, but it's including them. So knowing these, let's translate each sentence into an equation, or rather inequality, it should say. Use x to represent the number. So we have 5 more than a number is less than 17. Okay. 5 more than a number is less than 17. Done. 5 is greater than 6 less than twice a number. Oh boy. So 5 is greater than 6 less than twice a number. Not 5 more than, but 5 is greater than, so that means that's where the inequality is. 6 less than twice a number. If 7 is subtracted from 6 times a number, the result is at least 10. At least is equal to, but you can also be greater. So 7 is subtracted from 6x, and it's at least 10. Okay, always read it back and it doesn't make sense. 10 more than a number is no more than 62. So no more means it can be, but it can't be more than it. So 10 more than a number is no more than 62. The sum of 3 times a number and 12 is, fewer. So it's less than, is fewer than 20. And sum is plus. So the sum of 3 times a number and 12 is fewer than 20. 1/2 of a number is less than 16. Of is multiplication. The sum of 5 and twice a number is at most 17. So you can be 17, but you can't be more than it. Okay. So those are just translating. They're not asking you to solve. We're just taking words and translating them into algebraic inequalities. Okay. So let's get into the little heavier ones where we're actually going to solve now. And like I said, you're more than welcome to pause or go back and email me any questions you have. Example 1, a school auditorium can seat 450 people for graduation. Okay, that's your total. Always put the totals at the end. The graduates will use 74 seats. So we have 74 seats. The total's 450. Can you be 450? Yeah. Can you have more than 450? No. You can be less than it or equal to it. So we have 74 seats for the graduates, plus the people attending, all the seats in the auditorium. So we're going to go ahead and solve. Subtract 74 from both sides. Your answer? Well, if you don't have a calculator, just remember, borrow this 5, make it a 4, make this a 10. You get 6, 10 minus 4, 4 minus 7. Oh, we're going over 44 minus 7. Or do this, 3, make this a 14. You get 7, and then a 3. Remember that from elementary school? Okay. All right, so you can have, and we don't leave it like that. That's sloppy. So it says how many, or it says write and solve an inequality to describe the number of additional people that gets in the auditorium. So 376 people or less can sit with the graduates. Okay, and that's an example of the kind of word problems you're going to get. And those are pretty much like our constructed response, or open-ended questions that you're going to see on your keystone that you're going to take at the very end of the year. Example 2, National Honor Society. We just did this one. Okay, we can do it again. The National Honor Society at MAHS wants to raise at least $500. So $500 is 500. Okay, or more, because you can want to erase at least that. So we just put our total at the end. Each student earns 50 cents for every quarter of a mile. How many miles will the students need to walk? So if that's a quarter of a mile, $1 would be a half a mile, and $2, it would be per mile. So let's just leave it like that. So you have to be aware and saying, oh, this is talking about a quarter of a mile, but it's $2 per mile. So when you divide both sides by 2, you'd have to walk 250 miles total or more to get the money you want. Example 3, Austin can spend at most $3.10 for lunch. So if you can spend $3.10 for lunch, you can't spend more than that. You're less than or equal to. He buys a hamburger and a drink for $2.15. Okay, so he spent that. How much does he have remaining? Now some of you might go, I would just subtracted that in my head and I'm done. Well, that's true, but here's the thing. As you're getting into higher and higher math courses, you can't use mental math as much. So you need to learn how to set up these equations and inequalities while they're simple so that as they get more complicated, you're able to solve. Okay, it says write an inequality, done, and see how much Austin can spend on his dessert with staying within his budget. So I'm going to subtract 215 from both sides. X is going to be less than or equal to 95 cents. So he can spend 95 cents or less. Example 3. Kara's bike shop rents bikes for $10 plus $2 per hour. For how many hours can she rent the bike if she wants to spend no more than 22? So she can spend 22, but she can spend no more than it, so she has to spend less. And so maybe it'd say, well, I'd subtract the $10, leaving her with 12, and divide by 2. But like I said, start setting them up so as we get harder, it is easier for you to know how to set them up. So she removes the $10 that she has to initially purchase. Okay, and so she's left with $12 divided by 2. That means she can bike 6 hours or less. Okay. Example 4, Caden weighs 160 pounds. He's loading a truck with 50-pound boxes. The truck cannot carry more than 1,000 pounds. If Caden rides in the truck, how many boxes can he load into the truck? Well, the truck holds 1,000 pounds, so you can't be more than 1,000 pounds. The kid, Caden, weighs 160, plus each box is 50 pounds per box. The truck cannot carry more. Okay, so if we subtract Caden's weight from the 1,000 pound limit, then we are down to, you can use your calculator, you can use mental math, you can go ahead and do this. You're gonna be left with 840 pounds. 800, 900, 1,000, yep. And then divide both sides by 50. So it's gonna be 840 over 50. You can slash out the zeros. So 5 goes into 8 once, 3 left over. So 34, 5 goes in 6 times 30. So 5 times 6 is 30, 4 left over. So 16 4/5 boxes. So they're 50-pound boxes. So I have 16 and 4. Well, can I take 17 boxes or can I take 16 boxes? Well, you can't take a part of a box, so you have to round down because it'd be more weight if you rounded up. So 16 boxes or less in truck. Okay. All right, last part. It says write an inequality for an equation in terms of T to represent each situation. A temperature of at least 40 degrees. So you are 40 degrees or you're more. A temperature of no more than 54. So you're equal to 54, but you can't be more than it. A temperature above 34 degrees would be greater. And here's the thing, if you're like, I'm not sure, well, pick a degree greater than 34 degrees. 37, is that above 34 degrees? Yes. A temperature of is equal to. Let T represent an initial temperature reading. After the rise of 5 degrees Fahrenheit, the temperature was between 70 degrees. And that doesn't make any sense. I think that something got cut off. So we're just going to ignore that. Okay. So these are your word problems. This was a little lengthy, but we did review and we thoroughly talked about word problems and multi-step. In your packet that I made, you're gonna have a worksheet like this. I took these problems, there's a big blank here, and put them on the back, and I reduced some. So I always give you guys 8 problems, but we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you can do 10 problems. Up here, this is how you're gonna do it. You're gonna solve the problem here. So you subtract 4, you get 14. Then you're gonna divide by 7, a negative 7, which is negative 2, but the sign flips. So x is less than or equal to negative 2. Nope, 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 nope. Oh, there it is. So W is for number 1. You can put a W there, but you don't know all of it. It's fine. But I'm just saying the answers are over here, so you can find an answer. If you can't find an answer, you must have did something wrong. So do the front and the back in your packet, and we'll go over it in class.